Okay, so now it's 10:30. So we will start our class. Okay, just open the INU Smart Campus apps to check your attendance and just enter 3353. Just enter 3353. 호재혁? 호재혁? 좀 안 들어왔네?
네, 들어와 있습니다.
왜 출석 체크 안 했어, 왜? So open the your cam, okay? 호재혁 출석 체크하고.
네.
강다은. 로니카? 오케이. 이상건 들어왔니?
네. 네, 들어왔습니다.
꼭 잘 듣고 있어?
네, 듣고 있습니다.
오픈 그 캠은 왜 안 켜요? 하여튼 뭐 직장 생활하면서 잘 듣고 있어?
네, 듣고 있습니다.
오케이. 김유현? 김유현 없고. 박지효? 원진이 없네. 세무회계학과 신주환. 내가 항상 관심 가지고 있는 신주환. 수업도 안 들었네. 오케이. 최예지? 아까 보이던데? 최예지? 태알 마린? 태알 마린? 오케이. 박나영? 티보? Okay, it's okay. Okay, so we will start our class. Okay, just open the INU Smart Campus apps to check your attendance. Just enter 3353. Okay. Okay, let me go to the once again. Our final term exam will be held on December 10th. 1 week later, okay? It will start from 10:30 and unlimited. I think you will cancel all of the exam, final term exam within 1 hour. However, our exam time is unlimited. So take your time. Okay, and I also explained the very important procedure. Okay, so after you finish your exam, you just have to write down in the chatting window your name, finished the exam. Okay, you don't have to say to me, Professor, I finished my exam. You don't have to do that because everybody, another student is solving the problem. So it means that if you say like that, it will interrupt other people. Okay. And also, this is very important. Take a picture and send it to me within 5 minutes. Okay, I will check the time difference between this one and this one. Okay, after that, submit answer sheet through e-learning. Okay. Okay. I also provided detailed information. Okay, from chapter 6 and chapter 7. Today we will cover chapter 8, chapter 9, and chapter 10. Okay, total score is 50, but you already submitted all of homework, so everybody already got 50 points. Okay, you see here. Okay, so everybody already submitted all of homework. Okay. Okay. Do you have any other question in the homework in final term exam? Any other question? Okay, so now we will go to the chapter 8. Okay, now we will go to the chapter 8 again. So do you have any other question in chapter 8, the course, or do you have any question in homework? Okay, so last time I explained the nucleosome assembly and disassembly procedure. Okay, so this is very important. Okay, and also another histone variant is H2a. Okay, this is the H2a is the H2a variant. Okay, especially the main function is that, so this is the promote region, and this is a transcribed region, and this is nucleosome. So when the H2a, so H2a is incorporated in the promote nucleosome, which is located in promote region, it means that it enhanced RNA polymerase 2. So this is RNA polymerase 2 recruitment in promote region. So it means that increased RNA polymerase 2 recruitment in promote region, it induces transcriptional activation. Okay, this procedure is important. Okay, and also we learned that what kind of the chaperone is involved in the H2a incorporation. So our homework, we cover this one. So usually the this one is so eviction of okay. So incorporation of H2a and the eviction of H2a, there are several histone chaperone is involved in this step. So question was that what kind of the chaperone is involved in the incorporation and the removal of H2a into chromatin. So incorporation is the this chaperone, and the SWR1 is involved in incorporation, and also this one is also involved in eviction of H2a from the nucleosome. Okay, so actually the answer was 1. Okay. Okay, and also we cover this one, and this was, we already solved this one in the chapter 8 homework number 2. So H2a is the highly located in the +1 nucleosome location. But in the human or mammalian, it was located highly positioned around -1 nucleosome position. Okay. Now we will go to the second subject, histone variant H2aX. So they have this kind of motif at the end. Okay. So usually the apt DNA double-strand break happens. So usually the DNA PK, for example, the full name is DNA-dependent protein kinase, ATM or ATR, is recruited in the DNA DSB site. At that DNA PK, they did phosphorylation of H2aX. So finally, they will make the phosphorylated form of H2aX. So we call it as gamma H2aX. Okay. And also we covered NHEJ and HR mechanism. It's like this, okay? Okay, so in our homework, we cover that. So when does phosphorylation of histone variant H2aX occurs when a double strand of DNA is cut, okay? And also choose the correct pairing of enzyme that phosphorylate H2aX and associate pathway is DNA PK and NHEJ or HR. Okay, and then let me go to the macro H2, another variant of macro H2A. So macro H2A, in addition to H2A, they have the macro domain is like this. So the main function of H2A, a macro H2A, we already learned in chapter 6. So they have participate in X chromosome inactivation, okay, like this. Okay, so we also cover the eviction mechanism. Okay, and also now we will go to the another first subject, Histone H3 variant, H3.1 or H3.3. It's like this, okay? Okay, we cover that there is a mechanism during the incorporation of H3.3 into nucleosome in Ubiquitylation. And also we cover that the mechanism in the heterochromatin region. The only difference is that the chaperone, okay, histone chaperone, okay. And also whenever replication, during the replication is happen, so usually the DNA replication happens, at that time also chromatin assembly is actively happens. So at that time, at this time, instead of H3.3, at that time, instead of H3.3, H3.1 is incorporated into the nucleosome, okay? Okay, and also we finally cover the Histone H3 variant, SAMP-A. So the full name of SAMP-A is the centromere protein A H3 variant. Okay, this is SAMP-A. Okay, so this is now we will cover important. So this is the SAMP-A, the incorporation of SAMP-A into the nucleosome in fission feast, and also we covered in human. Okay, so we also cover this one in our homework. Okay, so okay, we also cover that they explain the mechanism during incorporation of SAMP-A into the nucleosome in fission yeast, and also they are in human. Okay, so in actual exam, what is main difference between the mechanism? What kind of mechanism? The incorporation of SAMP-A into the nucleosome. There's two types of the mechanism, nearly similar, but in fission yeast, especially the difference is that incorporation is happen during the G2 phase. The new SAMP-A incorporation is happen during G2 phase. Okay, for example, the SIM3 is the histone chaperone, deliver new SAMP-A. Okay, so at that SCM3 capture, this is SCM3 capture new SAMP-A. At that SAMP-A assemblies happen. this is fusion yeast. However, in human, sample A assembly incorporation is happen in G1 phase. So the chaperone is different from the fusion yeast, but you don't have to memorize the chaperone name. So I will give you the picture, but you have to explain the difference between the fusion yeast and human. The main difference is that in human, sample A assemblies happen during the G1 phase. Okay, so usually the HJURP and sample A, new sample A is recruited during the G1 phase. After that, it recruits the RSF. After finally the sample A assemblies happen. Okay, and also the main difference is that so the assembly site in fusion yeast is the when there is a Mis6 chaperone is located there. This is the assembly site. In human is CCAN. CCAN is new sample A assembly site. Okay. For example, this is Mis6. So new sample A is assembly is where the Mis6 is located. However, in the human is also another protein. This is the CCAN. This is the new sample A assembly site. Okay. And also we cover distribution of nucleosome containing sample A. Okay, so centromere contains around 200 nucleosome. Okay, among the 200 nucleosome, only 30 nucleosome contain the sample A. And also they are directionally distributed toward the kinetochore binding site is like this. Okay, so we cover this one in our maybe in multiple choice. I don't know in chapter 3. So how sample A is placed in the centromere during mitosis? Okay, means that sample A is directionally distributed in the centromere toward the site that kinetochore attach. Okay. Okay. Do you have any other question in chapter 8? Okay. Okay. So in our chapter 8, we have the four question is there. So I already explained the four question. Okay, so let me go to the chapter 9. So may I have a 1 minute breaks? Just I need water. Okay, 1 minute break. Okay. 강다운 출석 체크 못했어? 오케이. 오늘 시간 끝났어, 강다운. 내가 수동으로 내가 해줄게. 왜냐면 출석 체크 요거 지금 오케이 다시 나중에 내가 수동으로 다시 해줄게. 오케이. 오케이. Just open your cam. Just open your cam. 이수연, 송지훈, 조용훈, 김유나. Open your cam. 송지훈, 조용훈. 오케이. 양현호. Open your cam. 이윤성, 레이알, 문경록, 한동혁. Open.
My connection is pretty bad and
Okay. It's okay.
sorry.
It's okay. 야, 수업 들으면서 캠 켜는 건 기본이야. 기본적인 예의 아닌가요? 내가 어떻게 알아? 수업 듣고 있는지 어떻게 알아? 기본적인 예의를 지키세요. 선을 넘지 마세요. 오케이? 오케이. So, 말을 해도 말을 안 듣는 학생들이 있네요. Okay, so I will go to we can go to the chapter 9. So do you have any other question in chapter 9? So chapter 9 is the chapter 9 question. Or do you have any other question in homework? So we will start chapter 9. Chapter 9 is Histone Ubiquitilation. So chapter 9 is they have 3 subjects. First one is Histone H3 Mono Ubiquitination. Second one is a reversible Histone Ubiquitination. Also in second subject, we will cover Deacetylation enzyme, and also we will cover proteasome. Finally, we will cover H2a Mono Ubiquitination. Okay, so first one is we go to the Histone H2b Ubiquitination, H2b UB1. Okay, okay. So this is the Histone ubiquitination, the procedure for H2b ubiquitination. And also we have another mechanism for H2a ubiquitination mechanism. So they have the same mechanism, okay? Okay, so we have to know the detailed procedure. Okay. So E1, E2, E3 enzyme is involved in the histone ubiquitination for H2b. Especially the name is E1 is that ubiquitin activating enzyme. So it activates ubiquitin, so using the ATP. So, and also another enzyme is the E2 enzyme. E2 enzyme is that we call it as a ubiquitin conjugating enzyme. So main function of the E2 is to establish thiol ester linkage with the ubiquitin. Finally, there is an E3 enzyme. E3 enzyme, we call it as the ubiquitin ligase enzyme. So this one is especially the recognized protein substrate and catalyze the transfer of the ubiquitin from the ubiquitin E2 to protein substrate is like this. Okay. So go to chapter 9 is we are mentioning about histone ubiquitination. So we have to know the specific mechanism of ubiquitination. Okay. And also we cover this one. in our homework, I think we cover this one, I think. Okay. For example, in our multiple choice, we have to know some specific function of E1, E2, E3. Okay. Okay, so but we have to know the detailed procedure, okay? And also there is the histone crosstalk by H2b UB1. Okay, so this is the H2b and this is H3. Okay, so histone ubiquitination happens. So they made the H2b UB1. So there is two models. First, so there is a histone crosstalk model. First model is wedge model, and the other model is bridge model. Okay, there are two models. So in our homework, there was a question about wedge model or the bridge model. So we have to know. You have to know the detailed procedure, okay, to solve the final term exam. Okay. The wedge model is the main function of wedge model. This is wedge. So wedge is ubiquitin, is creates gap. At that step one is recruited. At that it will induce maturation in the H3 through the gap. Okay, how about the bridge model? So ubiquitin function as a bridge between the H2b and H3. So at that step one is bind to the ubiquitin and maturated the lysine residue in H3. It's very important, okay? Okay, so two model is involved in histone transcrosstalk, okay? Because the main subject in our chapter 9 is histone ubiquitination, okay? And also we cover the important step of the role of H2b UB1 in histone transcription initiation. Okay, so they are induced H3K4 and H3K79 maturation. So in our homework, we have to know to solve the problem. Okay, for example, okay, so this one, okay. Okay, so this is the role of the H2b UB1. We already solved this question in homework. Okay, and this one is the role of H2b UB1 in transcription elongation. Okay, there are another mechanism of the role of H2b UB1 in transcription elongation. Okay, so this function and this function, they are totally opposite. Okay, but we observe the two mechanisms. Okay, so H2b UB1, they have two roles, but they have two roles in the transcription elongation, but their role is totally opposite. Okay, so this is explain the role of H2b UB1 in the transcription elongation. Okay, this is very important, very important. So you have to explain this procedure to solve the final term exam. Okay, so I will explain it once again. During the elongation step, PAF is the polymerase associated factor. This is a transcription elongation factor, is bind to the C terminal of the RNA polymerase 2. So RNA polymerase 2 has a long C terminal. So they find this one bind to the C terminal of RNA polymerase 2. After that, it recruits another lead-6, and the brave one is the ubiquitylation enzyme, resulting in the mono ubiquitination in the H2b. After that, another chaperone. This one is recruited another chaperone. Fact is involved in the nucleosome disassembly and assembly. So this one is selectively associated with the H2a, H2b, UB1 dimer. After that, it facilitates the disassembly and also the fact is doing the histone. They have another function of the histone Ubiquitylation. After that, fact is facilitated H2a, H2b reassembly. So it means that based on this mechanism, is the H2b UB1 is facilitate histone disassembly and also histone reassembly, which is crucial for efficient transcription elongation. Okay. Okay, you don't have to memorize the specific protein, but you have to explain this procedure, okay? And also this is the also another evidence to show the role of H2B-UB1 in the chromatin dynamics. So based on, we can compare the sedimentation coefficient of nucleosome containing H2B-UB1 with nucleosome containing H2B. Okay, based on this one, based on this centrifugation, for example, nucleosome containing H2B shows that higher sedimentation coefficient. So they are located around at the bottom. However, the nucleosome containing H2B-UB1, they shows the lower sedimentation coefficient because they are located in the middle. So based on this experiment, we can say that nucleosome containing H2B-UB1 has a more root structure than nucleosome containing H2B. Okay, so this is another evidence. Okay, so we already covered this one in our homework. Okay, this one. To explain how to investigate the result showing that chromatin consisting of the nucleosome with the H2B-UB1 instead of H2B has the root structure. So based on this, so you have to explain this procedure, okay? Okay. After that, you have to do first. You have to make the nucleosome in which all of H2B is substituted with H2B-UB1. After that, you have to compare sedimentation coefficient. So you don't have to show this the equation, but okay. So after that, okay, that just based on the centrifugation. So you have the explain this one is they are located at the bottom, and this one is located in the around the middle status. So it means based on this result, we can say that like this, okay? Very important. And also, now we'll go to the second subject, reversible histone ubiquitination, deubiquitination. Good. So there are several deubiquitination enzymes involved. And also there are we have to know the component is proteasome. So main function of a proteasome is like this. They have the proteolytic function, but they also have another function, which function as the chaperone. This is a non-proteolytic function. Okay, for example, histone is composed of the 19S and also 20S core. And then again, they also have another 19S proteasome is like this. Okay, so 19S proteasome has 6 ATPase, so we can make the mutant. So they have some. This is the they have the function of the mutant. Okay. So by using the mutant, we can find that the non-proteolytic function of 19S proteasome. Okay. Okay. So this mutant to show that they made the temperature sensitive mutant for ATPase. Okay. Okay. For example, they have a normal function at the low temperature, but they have changed function, altered function at higher temperature. But at higher temperature, they don't have any problem in proteolytic function, but they have a problem with a non-proteolytic function, especially like this. Okay. So based on this one, so we can find that 19S proteasome is involved in specific binding of set 1 to chromatin. So they have this kind of chaperone function. Also, they have another function is they are very important role in the mRNA export based on this experiment. Okay. Okay. So now we will go to the H2a Mono Ubiquitination. They have the same mechanism. Okay, so we also covered E3 ligase for H2a. They have the ring 1 and H2a herb is involved in the ligase. Okay, and also in the multiple choice, we have a multiple choice to explain this procedure. So this is the histone crosstalk, trans crosstalk by H2b UB1. Previously, we covered histone trans crosstalk by H2b UB1. So we have two model, wedge model, and we also have another bridge model. You have to know. And also another mechanism is involved in histone trans crosstalk by H2a UB1. So this is the main function of the H2a UB1. Okay. So usually the MLL3 is the methylate H3K4. However, H2a UB1 inhibit the activity of the MLL3. It means that it will induce decreased H3K4 methylation. So this is the trans crosstalk by H2b UB1. So this is H2a, H2b UB1 is induced some function at H3. They have trans crosstalk by H2a UB1. Okay. Okay, and also, so in our homework we covered that. So choose the wrong one for H2a UB1. Okay. Okay, so the function of H2a UB1. So this is the nucleosome. Okay, so to make the nucleosome, we need histone H1. So without linker H2H1, nucleosome become the open and flexible structure. However, H2a UB1 help the histone H1 bind to the nucleosome. So with histone H1, nucleosome becomes more compact and rigid structure. Okay, finally, it will make the compact chromatin structure. So, okay, so in our homework, to choose the wrong one for H2a UB1. So this is the wrong one. Actually, the H2a UB1 help histone H1 associate to the nucleosome, not dissociate from nucleus. This is the wrong one. Okay, so and also they have several functions here. Okay, and also the main. So histone H2b ubiquitination, so they will make the loose structure. However, H2a ubiquitination, they have opposite function. So they make the compact chromatin structure. Okay. So do you have any other question in chapter 9? Okay. So chapter 9, we will have the we will have five questions. Okay. So I already explained some detailed information. Okay. So we will go to the chapter 10. Okay. 다들 수업 잘 듣고 있나요? 잘 이해가 되고 있나요? 김준웅.
네.
잘 이해하고 있어?
네, 수업 잘 듣고 있습니다.
Okay. Tibor, do you have any other problem in our lecture?
No, not for the moment.
Oh, okay. How about Marcin? Are you okay?
Yes, I'm okay. I found that Leia is not here. Okay.
Yeah.
Oh, where is Leia?
Yes. Can't you hear me?
Okay. Oh, yeah. Okay. I can hear you. Okay. Oh, you are here. Okay. Okay. I also found that T.R. Marin, she's not here. Please say to her, and our today's summary is very important. Okay. 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 세무회계학과 신주환 수업 안 들었지? 수업 안 들어놔서 항상 안 들어오네. 로니카? Okay, so Ronika is not here. Please say to her, today's lecture is very important. Okay. So okay. 장규민, 수업 잘 듣고 있어?
네, 잘 듣고 있습니다.
장규민 학번이 높은데. 오케이, 잘 준비하고.
네.
Okay. Okay, now we will go to the chapter 10. So do you have any other question in course or the homework? Do you have any other question? So chapter 9 is very complicated, okay? There are lots of subjects, okay? Do you have any other question in chapter 9 course or chapter 10 homework? Okay, so I will explain it. So chapter 10 is the main title is the histone acetylation and deacetylation. First of all, we will cover the histone acetyl transferase, and also we will cover Saga complex, also cover NUA4 complex, also cover P300. Also, we will cover Brom Domain. Finally, we will cover Histone Deacetylize. Okay, so this is the first subject, discovery of histone acetyl transferase. Okay, very important. Previously in chapter 9, we covered histone ubiquitination. At that time, the mechanism of histone ubiquitination was very important. And this is the histone acetylation. The mechanism of histone acetylation is very important. Okay, so this is the the lysine, the amino acid, the lysine. Okay, but if you already take my protein engineering course, maybe you guys already memorized the lysine structure. So this is lysine. So this is the C alpha, C beta, C gamma, C delta, C epsilon. So this amine, we call it as this amine is attached to the C epsilon. So that's why we call it as epsilon amine. Histone acetylation means that add acetyl group into the epsilon amine in the lysine. Before acetylation, so they have the lysine has positive charges, and also the DNA is negatively charged. So it means that it can easily, before the acetylation, chromatin can be easily, they can make the closed chromatin. They will be very complex structure. However, so we can add the histone acetyl transferase, add the acetyl group to the lysine. Okay, so that's why the acetylated lysine lose the positive charges. It means that it will result in weakened interaction between the histone and the DNA. So it will make the relaxed chromatin is like this. Okay. This mechanism is very important. Okay, you have to memorize it, okay? And also there are several types of histone acetyl transferase is available here. Type A is usually located in the nucleus, and type B is located in the cytoplasm. Okay. So let me go to the overview of histone acetyl transferase. First of all, we will cover GNET family, which is located in the nucleus, type A HAT. And also we will cover another one, the MIST, is also located in the nucleus. Okay, so also we will, okay, let me start from the GNET family. GNET superfamily is they did Histone H3 acetyl transferase. Especially they have a GNET domain. So GNET domain they have several motif A, B, C, D, especially in motif A, they have alpha 3 helix. So usually the alpha 3 helix combined with the acetyl coenzyme A, except that acetylation is happened. Okay, especially the alpha 3. How about in MIST family? MIST is also located in the nucleus. MIST is histone H3A4 acetyl transferase. So they also have some GNET homologous domain, especially the alpha 3 is also combined with acetyl coenzyme A. Okay, and also there are some specific mechanism of acetyl transferase mechanism in GNet superfamily. We call it as a sequential. They have this is detailed information of sequential acetyl transferase mechanism. And also in the mixed family, we call it as ping pong because this mechanism is reversible. However, in GNet family, the acetyl transferase mechanism is just the one way. This is the difference. Okay. Okay, we have to know some. Okay, so especially the alpha 3 helix is bind to the acetyl coenzyme A. Okay, usually the 2 amino acid in GNet superfamilies involved in the acetyl transferase mechanism. Okay, you don't have to memorize the amino acid, but you have to know the mechanism. Okay, so I will give you the picture. Okay, so you don't have to memorize each one, but you have to explain the procedure. Okay, okay, this is sequential and this is ping pong. Okay. Okay, in the ping pong mechanism is a little bit simple than the sequential. This is a sequential and this is the ping pong. Okay, so usually the glutamate, they have a carboxyl group. So because the carboxyl group, they are electron-rich carboxyl group in glutamate 338. So this is the lysine. Finally, they have a NH3 plus like this. So this group is the deprotonate from the lysine. Okay. Okay. At that, nitrogen in the lysine, okay, performs the nucleophilic attack. Okay, so finally they make the tetrahedral intermediate. And also dissociation of coenzyme A and SH is happen. So this is acetyl coenzyme A. But finally, this one will become the coenzyme A, SH. And also finally, they will make the acetylated lysine is like this. This is the glutamate 338 will become the OH is like this. Okay. Okay. So you don't have to memorize the protein name, but you have to explain the procedure. Okay. One of the ping pong or one of the sequential, okay? So because this is a histone acetylation, so this mechanism is very important, okay? Okay, and let me go to the Saga complex. Saga is also, this is also belong to the GNet superfamily, okay? And Saga has 4 modules. So in our homework, we covered that. This one is the Saga had several complex, so which is not corresponded to the module of Saga complex. So they don't have the methylation module. Okay. Okay. And also Saga, they have the Brom domain. Okay. Okay, so they have HAT module and they have the SPT, TAF, and also they have the Deubiquitination module, which is very important for the mRNA export. Okay. So this is the role of Saga complex in transcription initiation. Okay. So Saga, especially the DCN5, induces H3K9 acetylation. Okay, so if that 3SNF complex is bind to the acetylated histone, because the 3SNF complex, they also have the Brom domain. So resulting in the facilitation of chromatin remodeling in the surrounding region. So we also covered our homework, the role of Saga, and also this is the another one is that what is needed when Saga and SNF are targeted with the promoter. What is the correct sequence? So usually the transcription peptides bind to the promoter region. If that Saga is bind, if that it recruit, finally it recruits 3 SNF complexes like this. Okay. So describe the function of a Brom domain in Saga or 3 SNF complex. Okay, so Saga or 3 SNF complex are targeted to promoter by the transcription factor. So first transcription factor is there. If that Saga or 3 SNF is targeted to that region. Especially the Saga and 3 SNF, they can bind to the acetylated histone because they have the Brom domain. So these bindings spread the histone acetylation and chromatin remodeling to the surrounding region. Okay. Okay, this is we describe the function of Brom domain in Saga or SNF and 3 SNF complexes. And also we cover explain the acetyl transferase mechanism in ping pong. We also cover the sequential. Okay. And also this is okay. Okay. Okay, so this is the role of a Saga complex in transcription initiation. Okay. Saga induces H3K9 acetylation. Okay, if that 3 SNF complex is bind to acetylated histone. Okay, so during the transcription initiation, usually the transcription factor was there at that Saga and 3 SNF complex. Transcription factor was first is there at that Saga and also 3 SNF complex. Okay, so let me go to the NU-A4 complex. So this is this one is belong to the MIST superfamily. So MIST is Histone H3 or H4 acetyl transferase, but especially the NU-A4 complex is the Histone H4 acetyl transferase. So they have 2 modules. First one is HAT module, or the other one, they also have a module which plays important role in DNA repair, DNA recombination, and DNA replication. Okay. And also we cover another histone acetyl transferase, P300. This is also belong to the type A HAT. So they have a Brom domain, also they have HAT. Okay. Okay, and also now we will go to the 6th subject, Brom domain. So Brom domain can bind to the acetylated lysine in the histone. Okay, especially the GCN5. Okay, they have a Brom domain. Also, they have HAT. So that's why Saga Saga, they have the GCM5. So it also can bind to the acetylated histone. Also, GCM5 has H3, so they can induce acetylation. Okay, so there are several kinds of protein. They have the Brom domain. Also, SNF also has Brom domain. Okay, so BDF2, they also have a Brom domain. Okay, they have several functions. It's like this. Okay. Okay, let me go to another subject is histone deacetylize. So they have opposite function of HAT. So main function of HAT, they can add acetyl group to the epsilon amine, but this is totally different, totally opposite. So they remove the acetyl group from acetylation, so resulting in tight interaction between histone and DNA. And there are several classes, class 1, class 2, class 3. And class 3 is the very famous one. This is the NAD plus dependent HDAC. This is the most famous one. Most of the histone deacetylase is belong to the class 3. Okay, and there are class 1, class 2, okay, and class 3 is the NAD plus dependent HDAC. So we covered this one in our homework. Okay, so choose which following HDAC uses NAD plus as cofactor. This one is class 3, is okay. Okay, and let me go to the main function, canonical function of HDAC. For example, okay, so in class 1, HDAC, the very famous one protein is RDP3. So RDP3 is the class 1 HDAC. So they have a canonical function, and also they have paradoxical function. Especially in the canonical function, RDP3L is involved in the canonical function. Okay, so the canonical function is removes the acetyl group. After that, they will make the they can induce the tight interaction between the histone and DNA. So finally, they will make the compact chromatin structure, and also they can induce transcriptional repression. However, there is some paradoxical function of class 1 HDAC1, especially the RDP3S. Okay. In chapter 1, we learned about the pervasive transcription. It means that, so this is the canonical mRNA. However, when pervasive transcription happens, there are different kind of mRNA can be made is like this. Okay. Okay. At that time, we didn't know some specific mechanism. Okay. Now we will see that some detailed mechanism. Okay. So usually the RNA polymerase II is bind to the coding region. After that, they will synthesize the RNA transcriptor. Okay, so during the transcription elongation step, usually the histone disassembly, assemblies happen. So at that time, so histone acetylation can activate cryptic promoter. So they will make the pervasive, they will induce pervasive transcription is like this. So during this step, histone acetylation can activate cryptic promoter. have that result in pervasive transcription. Okay, so you have to explain this procedure. Okay. However, the RNA polymerase 2 has a long tail C-terminal domain. So long tail of CTD is phosphorylated. When phosphorylation happens, STAT2 is bind to the phosphorylated CTD. They can induce maturation, so like this. We already mentioned, so we have to see some detailed mechanism, but the main function of STAT2 is they can induce maturation. So finally, the RDP3S, this one, they can bind to the methylated region. So they can bind to the methylated region. And also the main function of RDP3S, they are HTAC, they have histone deacetylation mechanism. So this one induces the deacetylation like this. So it will prevent the cryptic transcription. So it means that only canonical mRNA can be actively transcribed. This is a paradoxical function of 3S. Okay. In our homework, we covered that choose the correct pairing for transcriptional regulation by RDP3L and RDP3S. The main function of RDP3L, they express normal transcript expression. How about the 3S? 3S, they also can express cryptic transcript expression. At that, and also 3S also, because they expressed cryptic transcript expressions, and they can paradoxically, they can actively transcribe the canonical mRNA. So this is paradoxical function of 3S. Okay. Okay, so now we cover chapter 10. We covered histone acetylation and deacetylation. Okay, especially this mechanism is very important. Okay, and also sequential or ping pong. One of them, you have to explain the procedure. And also we cover there are several roles of Saga in transcription initiation, and also 3 SNF complex. And also final subject is important one. Chapter 10 is cover deacetylation. So now we cover the function of deacetylation. Especially we focused on the class 1, especially 3L, 3S. 3L is involved in canonical function. They have canonical function, but 3S, they have a paradoxical function. So 3S, they can prevent cryptic transcription, but they can paradoxically, they can actively transcribe canonical mRNA. So this is the paradoxical function of 3S. Okay, histone deacetylation mechanism is also very important, especially the paradoxical function of RDP3S. Okay, do you have any other question? Okay, so actually this is our book, Epigenetics. So we covered all of the important chapter. Okay, so we finished all of chapter. chapter 10 is located here. Okay, so they also have chapter 11, chapter 12, but I think the chapter up to chapter 10 is important. Okay, so we finished all of our textbook. Okay. Okay, so do you have any other question in our final term exam? Do you have any other question? So actually the epigenetics class is very difficult to understand, but I found that all of them study is very hard. So during the midterm exam, I think nearly all of students had a good score. I think in the final term exam, I think nearly all of students will have a good score, I think. Okay. Okay, do you have any other question? Okay, Marcin.
Yes.
After you finish this semester, do you come back to France or do you stay here?
No, I stay in Korea.
Oh, okay. Even after finish the semester, this semester.
I do again another semester next year.
Oh, okay, okay. So maybe you can do some travel in Korea.
Yeah.
Okay. How about Tibor?
I'm only here for one semester, so I'm going back in December.
Oh, okay, okay, okay. And good luck. Okay.
Thank you.
Do you have any other question? Okay, today we will finish class. Okay, bye.
감사합니다.
Okay.
감사합니다.
Okay.